Hi, crew. So we're going to start today with our goal over here of what strategies can we use to place rational numbers on a number line. So rational numbers are numbers like 1, 2, 3, whole numbers. They're also numbers like -1, -2, -3. Later on this week, we're going to talk about placing positive and negative fractions and positive and negative decimals. Today, we're going to focus on getting familiar with number lines. So my hope is that prior to today, you've done a lot of work with number lines. Now, you guys know how much I love ratio tables, which is a lot. I love number lines almost as much as I love ratio tables. So with all of our answers today, we're going to go ahead and draw a number line to support our answer. And I want you to have those in your warm-up notebook as well, so later on when you go home, you have a really great reference to look at. So starting with our first problem, this says one morning, the temperature is -28 degrees Fahrenheit in Anchorage, Alaska, and 65 degrees Fahrenheit in Miami, Florida. Now hopefully you have some background knowledge to be able to answer that question. But using just our numbers there, I'm curious, which one do you think is warmer? So Vance, we're going to start off with you. I want you to just tell us which one you think is warmer. Okay. Do you agree, disagree, or have a question? Oliver.
I agree.
Okay, how come you agree?
It's because Florida is 65 degrees Fahrenheit, and Anchorage, Alaska is -28 degrees Fahrenheit.
Okay, we're going to put those on a number line in just a minute to see where they're located to help prove our point. Yeah.
Also, you could also look at Anchorage, Alaska. That's more farther up to near the.
Oh my gosh, you're using your geography knowledge as well. That's amazing. How did you do in the geography bee? Oh, just curious. Okay, so crew, I want you to start off by drawing a number line like this. And I'm going to put 0 on here. It does not have to be in the middle. I'm actually not going to put 0 in the middle of mine. Okay, and we're going to put those two temperatures. So I'm going to put Miami, Florida at 65 degrees on the right-hand side of my number line. This is where all of my positive values are going to be located. Now I'm also going to try and to make this proportional, which means if this is the distance for 65, okay, -28 is close to 30, which is close to half of this amount, okay? So if I think about it, 30 degrees would probably be right about here. But the temperature in Anchorage, Alaska is -28, which means it's going to be on the negative side of 0. And it needs to be about the same distance from 0 as 30 is. So I'm going to put it on the opposite side. Try and have about the same distance away from 0. And have -28 degrees. Okay? So you're trying really hard to make those proportions. I can see that you guys are working really hard with this on your number line right now. Good job. So we know that it's warmer in Florida. So let's also put a sentence. It is warmer in Miami, Florida. On our number line, we can see that it is more in the positive direction on our number line. It's further to the right. All right, and then letter B says, how many degrees warmer was it in the hotter location? How do you know? Who has a strategy for how we could solve this one? Adam, what are you thinking?
Well, what I thought is you could, so if 65, like away from 0 is obviously 65. And then on the negative side, -28 away from 0 is 28. So you could just add those two together.
That is an amazing strategy. So this is what I heard you say, that you want to start with, this distance right here, and that would be 65. And then you would like to add this distance right here, which is 28. You want to add those together. Cool. So we have 28 plus 65. Yeah, let's add those together. And we should get 93. Let's do a complete sentence. Look, guys, we have a number line and an equation. Write that down. And we're going to go ahead and give a sentence and say it is 93 degrees warmer in Miami. I like that you explained how we can think about that with our number line. So 0 is a great point to get to. All right, C says, which location has a temperature closer to freezing? How do you know? Now let's first of all talk about what temperature in Fahrenheit is freezing. For water, we'll say. Penny, do you know? It's not like 32, it is 32. Yeah, you got it. So on our number line above, let's just make a little tick mark for 32 degrees. Because that's freezing. And maybe I should have said, which location has a temperature closer to like the freezing point? But we're gonna see which one is closer. All right, who has a strategy for how we can figure out how far Miami is from freezing? Emma, what are you thinking? Will you talk nice, loud, and clear so we can pick it up on the microphone?
So you could subtract 65 from 32, and then you could subtract, and then for minus 28.
Let's just start with that first one. Is that okay? So yeah, if we have 65 as our distance, and we're going to take away 32, that's going to tell us how much we have left. So let's start off with Miami. Okay. Which has a temperature of 65. Okay. We're going to subtract 32 to find our distance, or our difference, sorry. So Miami is 33 degrees away from freezing, the freezing point. All right, Emma, would you like to continue with how we could figure out how far Anchorage, Alaska is from the freezing point?
Yeah, I'm gonna kind of guess.
Yeah, go for it.
But I think kind of like what Adam did is it was 28 like on the number line. The 28 is 28 from the 0.
So if we go from negative 28 to 0, that would be to add 28. Okay.
And then once you add 28 to 32.
So this, so you want to go to this point? Okay, Owen, what do you think about that?
That is
Okay, would you like to add anything? Okay. So then let's do Alaska. And we have that first distance of 28. And we're going to add that to our second distance of 32. Add those together. And Alaska is 60 degrees away from freezing. So which of them has a temperature closer to freezing? What do you think, Kai?
Probably Alaska.
So this one is 60 degrees away from freezing. And Miami is 33 degrees away
so
from freezing.
probably Miami.
Yeah, because it's only 33 degrees. So let's write a sentence and say Miami is closer to freezing. I hope that you have some beautiful number lines in your learning or in your warm-up today. I'm seeing some great ones from where I am. Okay, we're gonna time travel just a little bit. And we're gonna talk about converting between improper fractions and mixed numbers. Take 10 seconds. Make eye contact with somebody. Give that person a high five. If you did not just give somebody a high five, go find somebody. I want you to tell them, first of all, partner one, I want you to tell them what you know about improper fractions. Partner one, tell them what you know about improper fractions. Go for it.
Okay, so they can also be
And 0. I appreciate that there were a couple of you who made sure you had a partner, even if that meant getting out of your seat. Good job. Partner two, tell your partner what a mixed number is. Go for it.
Okay. So it's one and a half. It's like when they're whole and then it's like when they're also yeah.
4, 3, 2, 1, and 0. So from where I was standing, it seems like you guys have some pretty good background knowledge about improper fractions and mixed numbers, which is great. So we're going to convert just a couple of these. We're going to take number 2 here. It's a little tiny, but I need more space. And we're going to start with 8/4. Now, crew, if you have other strategies, and some of you do, to convert this, awesome. Our goal right now is to put this work on a number line. Okay, so we're going to represent this on a number line. After today, you use whatever strategy you would like, but I want you to represent this on a number line for now. Yeah. I'm going to show you with the number line first. Do you want to try it? Yeah, let's see. Yeah, come on up. Grab one.
So and then let's say 8/4 is right here. 8/4, and then if you see, this would be
We're going to turn it into a mixed number.
right.
I'm going to take it. Can I use your number line? Is that okay? Awesome. Okay. So we have 2 parts to this. So we have our numerator on top, and we have our denominator on the bottom. So I'm going to use those vocabulary words. So it is my goal to figure out how many wholes are part of this, okay? So my denominator tells me the size of my pieces, and my numerator tells me how many pieces that I have. So underneath here, I'm going to sketch out a number line here, and it's actually going to end up matching up with the one above it. And I'm going to show you how we can get from our improper fraction to our mixed number. So I told you I had 8 pieces that are the size of a 4th, okay? So there are, how many 4ths in a whole? You can just tell me.
1.
Not 1, there's 4, yeah. So I'm going to go ahead and put 4 4ths in one whole, okay? So to get to this one whole, I have 1, 2, 3, 4. Okay, so that's 4 4ths. But how many 4ths do I have? How many? 8. Okay, so I'm going to do 4, 5, 6, 7, 8. So I can say that 8 4ths is equal to 2 is equal to 2 wholes. Okay? Let's do our next one. Our next one is 13 ninths. Okay? I want you to draw another number line. These are all going to be positive, so we'll just keep the positive side of our number line. And just for now, we'll just put our number line up to 4. Okay. So we have 13 ninths. Elizabeth, what are the size of our pieces? How big are they? Ninths, yeah. And Brooke, how many pieces do we have? We have 13, oh great. So between 0 and 1, that's going to be 9 ninths. Okay, so let's go ahead and draw 9 little jumps, and each of those is going to represent a ninth. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that represents 9 ninths. How many more ninths do I have? How many do I have, Kira? I have 4 more to get to 13. So I have 9, 10, 11, 12, 13. So that's 4 out of 9. Okay. So 9 ninths I can represent as 1 whole. So this lets me know that I have 1 whole and 4 ninths. Yeah.
Well, I know another way that
And you know what? After today, you use that way. But our goal right now is to make sure we can do it on a number line. Yeah. But after today, that's awesome. Do you want to tell us your way for 11 thirds and then see if it works on our number line?
like, did you add a line or should I not?
Well, how would you do 11 thirds? And then let's check it using a number line.
Okay, well, what I do is, well, you can see how many times 3 goes into 11.
Okay.
That goes in 3 times, which equals 9.
Mhm.
And then you subtract 9 from 11.
Mhm.
And you get 2. And so then that would be 2 11s, 9 into 11s.
9 into 11s.
I mean, wait,
Let's check out our number
3.
line.
No, 3 into
Okay. Let's check it out here. So you were thinking 3 and 2 11s? Okay, let's double check it. So we have 11 thirds. For now, let's have our number line. We'll just go to 4 again. Okay. So every time I have a 3 thirds, that's 1 whole. Okay. So I'm going to go, let me switch colors here. 1, 2, 3. That's 3 thirds. And then I have 4, 5, 6. That's another 3 thirds. 7, 8, 9. That's another 3 thirds. And then 10, 11. And that would be 2 thirds. So when I count these up, I have 1 whole, 2 wholes, 3 wholes. So I have 3 and 2 thirds. So your strategy was very close.
And I just mixed up.
Yeah. So yeah, 3 goes into 11 3 times. And then we have 2 pieces the size of a third left over. Yeah. All right, before we move on, what questions can I answer? All right. Now we're going to look at going from a mixed number to an improper fraction. Okay, so we're going to start with 3 and 1/4. Okay, so sketch your number line. And we'll make our number line go up to 4. Okay. And we know that the size of the pieces that we're going to deal with are going to be fourths, because that's what our fractions are. So we have 1, 2, 3, and 1/4. Between 0 and 1, how many fourths do we have? Who can tell me? 4 fourths, yeah. So between each of these whole numbers, we have 4 fourths. And then this last little piece, we have 1/4 left over. So that means we have 4, 8, 12, 13 pieces that are the size of a fourth. So we can say this is the same as 13 fourths. Okay. I'm going to pause our video for just a minute. And I want you guys to work with your partner to see if you can figure out 6 2/5 and 8 5/9, what those would be as improper fractions. Go for it. So I drew a little picture for you guys. And I made this go up to 6 2/5. And between every whole number, I have 5/5. So I have 5/5, 10/5, 15/5, 20/5, 25/5, 30/5, 31, 32. So this is the same as, if I do 6 2/5, that would be the same as 32/5. Now, does somebody have an algorithm that we could also use to solve problems like this and explain why it works? Owen, would you like to take this on?
What number?
Oh, hold on, let me get caught up with you. Let's do it with 8 5/9. Okay, I'm all ears.
8 and 9 is the whole number multiplied by the number is split into parts.
Okay.
And add that to the numerator is the overall number of parts in the bracket.
All right, so tell me again, why do you multiply 8 times 9?
8 up into 9.
Okay, and in this case, how many 9s would we have? Okay, and then you said to add 5. How come we need to add 5? Good job. So what would this be equivalent to? 77. Thanks. You can also do it that way. Nice job. Okay, crew, we have one more. Your notes are beautiful. You're going to be so excited when you go home and you can look back at your notes. So we're going to look at one more. And there's an important vocabulary word that I want you to see here. So I want you to draw a number line like this. Okay? And I want you to find 4 numbers for me. I want you to find 2, 4, -2, and -4. Okay? Can you go up really fast and tell us where 2 is? Will you go really fast and tell us where 4 is? Can I have a volunteer do -2? Brandon, you go do -2. And somebody who has not heard from yet, Lily would go to -4. So here's an important word that you need to know. So we have examples of opposites. And what I want you to notice, you tell me, what do you notice about 2 and 8? What do you notice about those 2? Nico, what do you notice?
They're in the same space away from 0.
Yeah. So if we look at this, 2 and -2 are the same distance away from 0. The same thing happens with 4 and -4, and they are also the same distance away from 0. Okay, so that's where we're going to stop today, and we're going to use this in our web quest.